Hello friends, in previous video we have studied that what is the physics, what types of the phenomena are studied in the physics, okay, some natural phenomena such as the repetitions, regular repetitions of the day and night, the annual cycles of the seasons, how eclipse will be formed. These all types of the natural phenomena are studied in branch of the science that is known as the physics. That we have done in previous video. Now today we are going to study what is the domain. So physics is classified in two domains. One is macroscopic and second was microscopic. And question is, what is the macroscopic domain and what is the microscopic domain? So the macroscopic domain including the phenomena at the laboratory, terrestrials and the astronomicals. In the macroscopic domains, we deal with some phenomena that is happen in the laboratories, that is in the astronomical scales, some the motions of the planets, okay, the motions of the earth, the some motions of the big particles. So these types of the phenomena we are studied in the domains of the physics that is known as the macroscopic domains. Now what is the microscopic domains? In these domains we studied some phenomena that is in atomic scales. That means the atomic, molecular and nuclear phenomena. Suppose we consider some atomic phenomena. In the atoms, electrons and protons are attracted to each other. So these phenomena will be studied in the macroscopic domains. Some interaction between proton and electrons, neutrons and electrons, some motions of the electrons, protons. These all phenomena are studied in domain of the physics that is known as microscopic domain. Okay. So now the physics branch which is help to understand some phenomena which is included in microscopic domain, that is known as classical physics. What is classical physics? This is the branch of the physics which is help to understand the phenomena which is included in the macroscopic domain, such as some phenomena which is happens in the laboratories, some astronomical scales, okay, planetary motions, earth, etc. Such types of the phenomena will be studied by help of the classical mechanics or classical physics. Now another branch of the physics that is help to understand some phenomena which is included in the microscopic domain, such as some atomic, molecular and nuclear phenomena, okay, that is known as quantum mechanics. Okay, so quantum mechanics is branch of the physics which is help to understand some phenomena which is included in microscopic domains, such as atomic, molecular and nuclear phenomena. So now next question. Which subject are included in classical physics? Classical physics is branch of the physics, but in classical physics some subjects are included, such as the mechanics, electrodynamics, optics and thermodynamics. So now question is, what is the mechanics? So mechanics is also a branch of the physics in which we deal with some planetary motions, the phenomena in which the Newton's law can be applicable, some gravitational force can be applicable. So that types of the phenomena and their studied will be done in the mechanics. This is the branch of the physics. Okay. Now second subject which is included in classical physics, that is electrodynamics. So explain in short the branch of the physics that is electrodynamics. So from the name of this branch we get some information about the electro, that means some electric and magnetic phenomena are studied in this branch. Okay, in our 10th standards we studied some principles given by scientists Coulombs, Oersted, Amperes and Faradays. The scientist Oersted give the principle, that is when the current is passing through a wires, then surrounding to that wires they create the magnetic fields. Okay, whenever the electric currents is passing through electric wires, so surrounding that wires they produce the magnetic fields. Okay, similarly the Faraday give principle, that is if the magnetic fields is changed with respect to time, so that produce the electric currents. So in this case, Oersted principle, this is the electric fields produce the magnetic fields, okay, and in Faraday laws, Faraday principles, the magnetic field produce the electric fields, okay. So these types of the phenomena are studied in the branch of the physics that is known as electrodynamics. Now the Coulombs, Oersteds, Amperes and Faraday, these all scientists are give some principles or theories in the electrodynamics. These all theories are combined by one scientist, that is Maxwell, and give the famous set of equation, okay. By combining these all principles given by Coulombs, Oersted, Amperes and Faradays, the Maxwell give 4 set of equations, okay. Also the Maxwell established the theory that is known as electromagnetic theory. That theory also we learn in the branch of the physics that is known as electrodynamics. So in short, in electrodynamics we deal with some electric and magnetic phenomena. Now next question, explain in short about the optics. So optics is also the branch of the physics in which we deal some phenomena that is involving the light. We also know that light have dual nature, particle nature and the wave natures. But the particle nature, that information or that concept we learn in the second domain, that is the microscopic, and at that time we use the quantum physics. But we know that light has the wave natures. So in this optics branch we deal with some optical phenomena such as the reflection. What is the reflection? What is the refraction? Okay, what is the dispersions? What is the splitting of the lines? How rainbow will be formed? Some phenomena which is due to some light, it is formed due to some lights. So that types of the phenomena we learn in branch of the physics that is known as optics. Now next question, that is what is the studied in the thermodynamics. So thermodynamics is also the branch of the physics. So from name of the thermodynamics we get some information, that is thermo, that means something related to heat. So suppose you have a system, and system have its internal energy, but due to the transformation of the heat from the system to surrounding, and by doing some work, this internal energy may be changed, okay. So how this internal energy can be changed, so these types of the information can be studied, the branch of the physics that is known as the thermodynamics. Also some terms, the entropy, enthalpy, the temperature inside the systems, these all factors can be changed due to the transformation of the heat and by doing some work between the systems and the surroundings. So these types of the phenomena we are studied in the branch of the physics that is known as thermodynamics, okay. So in classical physics there are 4 subjects. First one is the mechanics, second one that is electrodynamics, third one that is optics, fourth one that is the thermodynamics. So these all subjects are deal with the macroscopic domains in which some large objects or planets, these types of the phenomena we are studying in that subjects. So now next questions, what is included in macroscopic domains? We have discussed earlier how types of the which types of the phenomena are included in microscopic domains. Some atomic, molecular and nuclear phenomena, okay, interaction between electrons, protons, neutrons, okay. These types of the phenomena will be studied in microscopic domains. And which branch of the physics which is help to understand these types of the phenomena which is included in microscopic domain, that is quantum mechanics or quantum physics, okay. So next question is, which theory is presently accepted to understand the phenomena of the microscopic domain? So that theory is quantum theories. This is MCQ questions, okay. Which theory is presently accepted to understand the phenomena of microscopic domain? So that is quantum theory. Now next question. Explain the range of the function of physics in terms of the length, mass and times. Now we find out what is the length in which the physics can deal, or physics can understand some phenomena. So we know that in physics we deal some small particles, very small particles, that is electron, protons, neutrons, neutrino, positrons, these types of the very small particles. So these particle size is in orders of 10 raised to minus 14 meter. This is very small length. Okay, so in physics we studied this very small length also. Okay, so this is the minimum length orders which is studied in physics. Also we studied some phenomena which is in astronomical scale. Okay, astronomical phenomena at the scale of the galaxy or even entire universe. So that phenomena whose length is in order of the 10 raised to 26 meters. This is very large, 26 meters, 10 raised to 26 meters. So by using physics we can study the length range, that is from 10 raised to minus 14 to 10 raised to minus 16. And what is the ratio of length range? So that is given by 10 raised to 6 meter by 10 raised to minus 14 meters, that is equal to 10 raised to 40 meters. Okay, so this is the length ratio. In short, by using the physics we can study the length range from the 10 raised to minus 14 meter to 10 raised to 26 meter. That means from the length of the electron, proton or small particles to the big particles or even the universe length. Okay, and we know that when we divide this length by the velocity of the lights, we get the time length. Okay, time range. We know that the velocity is given by distance by time. We have the length. This is velocity, is light velocity we take. So t is equal to L by V or C, that is light length. So when we divide the length range by the velocity of the lights, we get the range of the times. So we know that what is the length range for these very small particles, that is 10 raised to minus 14 meters. When we divide this length by velocity of the lights, that is in order of the 10 raised to 8, because this is 3 into 10 raised to 8. So we take only order terms, that is 10 raised to 8 meters per second. This meter cancel. You get the small time range, that is 10 raised to minus 14 minus 8, that is 10 raised to minus 22 second. So by using physics we can study the phenomena which is lies in times 10 raised to minus 26 seconds, 22 seconds. This is very small time periods, but by using physics you can study that phenomena also. Now what is the large range of the times? Okay, so for large length of the galaxy, that is 10 raised to 26 meters, divide by the velocity of the lights, meter per second, you get 10 raised to 18 meters. So this is the large range of the times. Okay, so we can using by physics we can study the phenomena whose time is lies from 10 raised to minus 22 second to 10 raised to 18 seconds. This is the MCQ questions. What is the length range? What is the time range? That is we using by physics we can study. Okay, so what is the length range? That is from 10 raised to minus 14 to 10 raised to 26 meters. This is the range of the length. Okay, by using physics you can study that phenomena in that length range. And what is the time range? That is 10 raised to minus 22 to 10 raised to 18 seconds. So this is the time range. So by using physics you can study the phenomena which is lies in this time. Now what is the mass range? So for that we know that we studied the electrons of very small particles. So that small particles mass is 10 raised to minus 13 kilogram. So this is our minimum range for the mass. We can also study the mass of the observer universe, that is the 10 to 55 kg. Okay, so what is the range of mass? That is 10 to minus 13 kg to 10 to 55 kilograms. So by using the physics, you can study the phenomena whose mass range is lies between 10 to minus 13 meter to 10 to 55 meters. Okay, so in short, in this theory, we remember some MCQ questions answer, that is what is the length range. So by using the physics, you can study the phenomena whose length range will be lies between 10 to minus 14 meters to 10 to 26 meter. We can study the phenomena whose mass range lies between 10 to minus 13 kg to 10 to 55 kg. We can also study the phenomena whose time range is lies between 10 to minus 22 second to 10 to 18 second. So this is the MCQ question. Okay, now we stop here. In next video we learn about the fundamental forces, that all things. Okay, thank you.